Hello everyone, welcome to this video where we are going to explore the applications of similarity. So let's zoom in. Well, previously we learned that for similar figures, the original figure actually either undergo a enlargement, which increases in size, or a reduction, which simply means that it becomes smaller, decrease in size, reduction. And the way we write the scale factor also indicates whether it is a reduction or enlargement. Okay? And the ratio, and this scale factor is actually the ratio of the corresponding sides of the two figures, be it enlarged or reduced. Okay, so these are some terms. The scale factor is this one. So the scale factor is actually a ratio of the sides. Okay, and what sides? The corresponding sides. So as we move on, and there is some interesting property of this scale factor. The very first thing is, you must know that we always used the enlarged or reduced figure divide by the original figure, the side of the original figure. Okay, so the original figure is the denominator. So it's either the enlarged or reduced. Okay, so I repeat, the side is either the enlarged or the reduced image. Okay, and one last thing to take note actually is that if the scale factor is more than one, enlargement. But if it is less than one, reduction. If it is equal to 1, then it is the exact same size as the original. Last thing to take note is that we should always leave the scale factor. If it is an improper fraction, leave it as an improper fraction. Okay? We shall now go through some examples on this particular part on the applications of similarity. Hello everyone, welcome to this example here where we will need to, first thing, we need to see what is the scale factor. 2/3 tells me that it is a reduction. Sometimes they don't say that it is a reduction. Okay? This means that all we have to do is to make sure that all the length is going to be reduced by 2/3. Okay? So for example, if I'm going to zoom in to this length, then I can see that for this particular length, then it is actually 1, 2, 3, 4, 5, 6. So the reduced length, I'm going to share with you the answer now, will then be the corresponding length here, which I'm going to zoom in. It's actually the original multiplied by the scale factor. So this one will give me 4. 1, 2, 3, 4. Yeah? And therefore, for all the length, they will undergo the same transformation, or the length will be 2/4. 3 of the original length. And you will then be able to come up with this final answer. So I'm going to give you another example. So for this, then I also count 1, 2, 3, 4, 5, 6. Therefore, this one will be 4. This one also will be 4. Small box. Then if I continue, 1, 2, 3, 4, 5, 6. This is also 6. As well as, all these are 6, okay? So you can see that all the length here will be 4 and 4. And lastly, as we continue, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then this one will be 12 times 2 over 3, which will give me 9, which will give me 8. So it will be 1, 2, 3, 4, 5, 6, 7, 8. Yep. Here will also be 8 since here will be 12. And after that, you just need to connect this last line, and it should also work with, if I were to count again, 18. Then this part here will actually be 18 multiplied by 2 over 3 to give me a value of 12. Okay? And that is how you draw a reduction of the figure. Well, let's move on to the next example. Hello everyone, welcome to this video where we are given that triangle ABC is mapped onto triangle PQR by an enlargement. Straight away, I know the scale factor must be bigger than 1. Okay, and how do we find the scale factor? So in this case, we just need to identify a corresponding side. And then the image, which is in this case 6, divide by the original 2 to give me 3. So PQR is actually 3 times of ABC. Alright, now that we know that triangle PQR is indeed 3 times larger than triangle ABC, then for part B and part C, it becomes relatively easier, because to find BC, I just need to look at the corresponding length, 4.5 cm, and I know this 4.5 cm is 3 times larger than BC, right? So for part B, the length of BC is simply 4.5. I'm going to divide by 3. And I get 1.5 cm. And it is indeed, for QR, it is indeed 3 times larger. Yeah? And for my PR, since I know AC, right? So PR is pretty straightforward already, because I know it is larger by 3 times. It is bigger 3 times. So it is simply 3.6 multiplied by 3. And I got my answer. Alright, let's move on to the next question. Hello everyone, welcome to this video where we are given that Emma uses a skill factor of 5/4. This tells me it is indeed an enlarged image. Now that we have the skill factor, they also share with us some of the sides that is given. So AF is 16 cm. Find the length of A apostrophe, F apostrophe. So this one I will just highlight it in green. We will then need to find this. And it is pretty straightforward because we know the scale factor. Meaning that this particular length is simply 16 multiplied by the scale factor to give me a value of 20 cm. So it is larger by 5/4 times. Okay? So if I look at the other way around, for BC, then I will have to look at my B prime, C prime, or B apostrophe, C apostrophe. This is my A. Then using the same idea, but this time round, we are trying to find the original length of BC. So you will then see Mr. Tan actually not going to multiply by 5/4, you know. Instead, I'm going to divide by 5/4 so that I can find the original length, which is the smaller length. Okay? And that will be 12.8. Alright? So we are done with part A. Let's look at part B, where we are then given that the length of the vertices C and F. Oh, this length here, I'm going to enlarge it, okay? It's 28.8 cm. So find the corresponding length here. Alright, so for this question, again, because it deals with length, right, then the same idea exists as well. Meaning that C prime, F prime, or C apostrophe, F apostrophe is simply 28.8 multiplied by 5/4 because it is the larger length. And that will give me a value of 36 cm. With that, we have come to the end of this video. If you like for this question, so if you like the problem solving steps, do subscribe to this video. Let's move on to the next question. Hello everyone, welcome to this video where we are given that a model airplane is made using a scale of 2/700. What this simply means is that given this scale factor of 2/700, this is my model and this is my actual or what we call the original. Okay? So now I know this. This is important because find the actual length in meter. Later we talk about the units, but we are given the length of the model, 21.8 cm. So how then can we find the actual length? Okay, so this is a really important thing because this tells me that the model is 2 units, and these 2 units represent 21.8 cm. Yeah? So I could actually use this method. And after which, I just need to find 700 units later, because that is what is represented by the actual length. So you will then see Mr. Tan find 1 unit, which is simply 21.8 divided by 2. That will give me 10.9. And thereafter, I will be able to find my 700 units, which is simply 10.9 multiplied by 700 to give me a value of 7,630 cm. And it is at this point that I go back to the question. The question requires us to leave my answer in meter. So I will have to divide by 100 to arrive at this final answer. With that, we have come to the end of this video. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day.